Now we need to look at integration rule 2. In this particular rule, we are checking or refreshing ourselves about e to the x. And the very first statement up here, I need to know. Remember, when you have f of x equals e to the x, that is its own derivative. So f prime of x is equal to e to the x. We need to know that in order to figure out how to do the integration rule. And this one is not that bad. So in this one, if this is my original function, my derivative of this should be e to the x. This one, my derivative should be y prime equals negative 8 e to the x. This one, I think you see a pattern, h prime of x equals 2.5 e to the x. So now I need you to check this, and with respect to going in reverse, which is what integration is, this isn't bad. If I see e to the x, then it's going to go back to the exact same thing, whether there is a constant involved or a coefficient of 1. So integration rule 2, here it is. If I have to integrate, I've got some coefficient times e to the x dx. The antiderivative of that is itself plus the constant of integration. Now in these particular problems, I put more terms in, some of the old rule we just had and the new one. So in problem 14, I have e to the x plus 3. Remember, 3 is the same thing as 3x to the 0. So e to the x's are nice. That should just be e to the x. The next part, I've got to do 3 over a fraction bar, and remember we add 1 to the exponent and divide by that new exponent. So in this one, I should have 3 over the fraction bar to the first power, and it should be divided by 1. And don't forget your plus c. The only thing I need to clean up here is this portion, so my answer should be e to the x plus 3x plus c. What I'd like you to do is pause me and then double check and see if your answer is like my answer. I'm going to keep on going. So in this one, this is the old rule. I'm going to have 1 over, it looks like I'm going to have a new exponent of 4, so I'm going to have 1/4 t to the 4th. See if I've got that part. I've got to find it first. Well, I've got that. There's that. Here's an e, so that's going to repeat. Negative 3e to the t. Just not making my box go far enough. Here, this is a coefficient of 1. Exponent is 1. So it looks like I'm going to have a 1 over 2 t to the 2nd, then plus my c. See the next part. Again, pause me, work these out. Negative 15 e to the x. So that's going to repeat as is. This is the old rule. That'd be a negative 7 over 4 x to the 4th. Still old rule. 12 over 1 x to the 1st plus c. And then clean up what fractions you can. The only one I can is this one. So that's the only way it changed. This one, I'd have a negative 5 over 5 x to the 5th. There's my e, so negative 2 e to the x plus, let's see, that'd be 3 over 4 x to the 4th plus 16 over 1 x to the 1st plus c. I can clean up this fraction and this one. So I should end up with a negative x to the 5th, negative 2 e to the x plus 3/4 x to the 4th plus 16x plus c. So that's my integration rule 2. So e to the x or e to the t, like I had in problem 15, they're not bad. They just repeat very, very quick. Now we've got another rule. we're going to find the derivative of the following. Remember, when f of x equaled natural log of x, remember that the derivative, f prime, was equal to, in this particular case, 1 over x, which is the same thing as x to the negative 1. So anytime we see something that's raised to the negative 1 exponent, it will integrate to involve the natural log. So let's look at this one. For me to get the derivative, that would be y equals, I'd have 5x in the denominator, 5 on top, and that would equal 1 over x. This one, I would have 9 times 1 over x as my derivative. This one, my g prime of x, would equal negative 2 over x. But remember, this is how we always did the problem. But what I needed you to see here, regardless, if you've got x, once you take it to the numerator and it becomes a negative 1 exponent, you're dealing with a natural log. So let's look at these 4 problems. In this particular one, let's see, I see negative 1, so this is going to be 3 times natural log of x. This is my old rule. So that would be a negative 10 over, let's see, I'm going to add 1, negative 1, so x to the negative 1 plus c. Clean this up. The only thing is going to be a plus 10 here, but everything else stays as is. Notice that this problem is not after the integral sign, so this is my final answer. It's only when it's in the after the integral sign, when it's raised to the negative 1, that you're going to end up with a natural log. So like before, work out these problems and then start me going again. First thing I want to do is rewrite this. So that would be negative 7x to the negative 1. This is old rule. This is our new rule, and this is just the rule we had a minute ago. So this would be 3 divided by 5, x to the 5th, minus 7 natural log of x. It's immediate. And this comes down as a repeat, plus 8 e to the x plus my c. This one, got to rewrite that. I need to see the negative 1 exponent. So that's the only way that that's the only thing that this problem is going to change, is this part. So now I see it. So this is 9 natural log of x minus 3 e to the x, and this is my old problem. That would be 7 over 1 x to the first plus c. So there's that piece, and I got to clean this up, so I just have 7 there. There it is. Try this one real quick. Let's see. This stays the same. This would be plus 2 natural log of x, and the x is put in absolute value. I didn't say that earlier, but you should have seen it. Plus, this would be 6 over, add 1 here, so that would be 3. 6 over 3 x to the third plus 3 over 1 x to the first plus c. So there, that repeated. There's my natural log of x in absolute value divided by 3 raised to the third. I think that's what I said. And clean up this piece and this piece. And there it is. So you've got some problems you need to do. Okay? I'll talk to you later. Bye-bye.